Exactly, exactly. So,
So it would be
mhm.
wait, so it would be 0.84134 is the
Yeah, 0.84134. And this is telling you the proportion, right? But very key to this is what I said earlier, which is, sorry, it tells you the area to the left. So what you have found is that, like, basically something like this. So the amount of area to the left of this number. So this being, um, like, we did it for 75, is that right?
yeah.
Okay,
Oh
so
no, we did it for oh yeah 75. Oh, 74% of the information is on the file 75
yeah,
or the data
what percent you said?
84.
It's saying, yeah, it's saying 84% is below 75, and the mean,
Yeah.
yeah, the mean is, they said the mean is 65, right?
Mean is 65.
Yeah. Okay. Cool. Yeah.
So
So,
now
go ahead.
so now can't I find do the same thing for 85
Yeah.
and
Correct.
subtract that from 84?
Exactly. Exactly. Now, if you did all of that, you'd find the number you'd find is 0.68. That's unsurprising. Why is that not surprising?
Because oh because this is one standard deviation.
Yeah. Exactly. Exactly.
As one standard deviation, like you said, is 68%.
Exactly, exactly. So what I was saying is we didn't need to use the table, because what we could have done is we could have just taken the mean, and our guess should have been like that these two numbers have to do with the standard deviation. So if we just add 10, the one standard deviation to the mean, we get to 75. And then if we add two standard deviations to the mean, we get 65 plus 20. That gets us to 85. So, like, we know that, um, sorry, and these numbers aren't symmetric. They're not on either side of the mean, right?
Yeah.
They're both on the same side of the mean. So the
Yeah, so it's on the right side.
exactly, exactly. So the visual you've got is like this is 65, and so we've got the amount for 75, and then we've got, as you said, the amount for 85. And if we want to know what percent is in between, obviously what we have to do, I should have shaded the second one in a different color. What we have to do is find the area. I will do it in purple right here. And how did you say we do that?
Um, what is the wait? What did it be? 34%?
34%.
What did it be? It's only one standard deviation.
Well, so one standard deviation would be the 75. Two standard deviations is the 85. The 85 is at 95%. So it would be 95% minus 68% that would fall in between.
Oh, okay. So and then
Go ahead.
I'm just confused. Wait, can you?
Go ahead.
Wait, what? So what's the easiest way to do this method? I guess.
Huh?
So the easiest way to do this method is get two z-scores and then. But I don't think I get that chart on the test.
No, you don't do the two z-scores. You need to be, for some of the questions that you have had to do here, that you sent me. You do need to be given the z table. But this is what I'm saying. So one standard deviation from the mean is gonna get you to 75,
Yeah.
and then two standard deviations is gonna get you to 85.
Sure.
Okay. Now, what you're interested in is what percentage will fall here. Well, we know,
Yeah.
yeah, we know that two standard deviations on either side of the mean is going to be 95%. And so
Okay.
95, yeah, go ahead.
Yeah. Yeah.
Yeah,
Okay. 95%.
yeah,
Oh.
95%.
Oh. And one standard deviation would be 68, so 95 minus 68.
Correct. But we need to do something about a little more than a little bit, a tad bit more than that. So you're right. Like we subtract them, but what's that little tad bit more we have to do?
Wait,
It's a 65.
Oh, or 68% of the data.
Oh no no no, you're right. You're right. My bad. Sorry. Um, I was my head was getting ahead of, or my mouth was getting ahead of my head. Okay, that's right. Okay, but once we subtract them, we have to do a little something extra. What do you think is that little something extra?
The proportion.
Well, okay. So first, let's subtract these two. 95. I have.
So
Go ahead.
wouldn't it be 27 after subtraction?
That's right. 27, but it's not
Would
27. Go ahead.
27% of the information falls to 75 based on, right?
Close. Like there's one little bit that we have to do. What's that little bit?
Is it because it doesn't
We have to divide by two. I'll tell you that. Why?
because I don't know why.
Because when we say like 95% or the 68%, we're saying on either side of the mean. So it includes both going right and going left. So like the I'm saying the 27% counts the area here, but also the area here.
Okay.
Make sense?
It needs to look a little bit. So
Mm-hmm.
because you're saying because here, so this right here
Mm-hmm.
and on is 75, or how many, not 75, is 95% of the data, right? Or
Mm-hmm.
no, 68% of the
Mm-hmm.
data
Mm-hmm.
is here and on.
Mm-hmm.
I don't understand. So from here and on is 65 or 68% of the data,
Uh-uh.
and here and on
Sorry.
95% of the
Cl-
data.
yeah.
And is it just 7%?
Yeah. Like so here, I'm saying from here to here, I'll use my arrow too. From here to here is 68. One standard deviation on either side of the mean.
So from here to this green line to here, 68% of the
Correct.
data.
Correct. So you move one standard deviation on either side of the mean. That's 68%. And then two standard deviations either side of the mean is 95%. So when you do
Okay,
nine,
I thought you were saying that. I thought you were saying that 68% of the data for here
That's what the z-score would tell you from there all the way to the left end. But these 68%, 95%, what they tell you is like in between the standard deviations.
Yeah. So 68% of the data falls between here and here.
Correct.
95 from here to here.
Exactly.
And then 97 point or 99.7 from like here to here.
Exactly. Exactly.
Okay, yeah, that makes sense.
Exactly. So if we want to know only what's in here, then we need to divide 27 by. Exactly.
Sure. Yeah.
Okay, cool, perfect. Now, problem 2 and problem 3 are very similar, but why not you talk about them? So go ahead, read them, and let's talk about them.
Problem two. The scores on a particular test are normally distributed with the mean of 65 and standard deviation of 10. What proportion of the scores are above?
I mean, very similar questions, slightly different.
Yeah. So kind of this. Well, I guess. Would it be like 2.5% of the data?
2.5% of the data, you said. I think you're absolutely right. So hold on. Sorry. So this is one standard deviation. That's 10. That'd be 75. Good. Your guess for these numbers should always be like they have to do with the standard deviation added to the mean. Okay. So then you're saying uh, 85 is um, right here, and that's two standard deviations. So if we go left and right, two standard deviations, then like we will have this area in between, and we're saying this area in between is 95%. Got it. And so then that means this little bit here at the tail end, this little bit here together are 5%. So they must be
Yeah.
2.5% each.
Yep.
Great. Okay. Go to the next one.
Number 3.
Uh-huh.
So, its scores on a particular test are normally distributed with a mean of 65 and standard deviation of 10, what proportion of the scores are above 45. So, I think hopefully the scores are above 45.
Write 45 somewhere on the on here. Like you can write with your mouse. So like on the
Yeah, no, I wrote it on my paper.
Oh, okay, you got it.
Uh,
Or point use your arrow and tell me where would 45 go in this bell curve?
55 would be here and then 45 would be here.
Exactly. So it's saying above, so you want it said above, so you want everything to the right of that.
Oh, I think maybe 97.
There you go, beautiful. Because everything between here and here is 95 plus this little 2.5 makes 97.5. Great. Okay, so I think the bottom part of this worksheet doesn't say anything. So let's go to the next page.
Okay.
Go ahead and read it.
The program for international students conducts tests in mathematics in countries throughout the world for 15-year-olds in all developed countries. The scores in 2012 were normally distributed with a mean of 494 and a standard deviation of 92. So, if this program mean that for 15-year-olds, the school can be normally distributed with a mean of 494.
Mm-hmm.
Standard deviation. Make an accurate sketch of the distribution of PIs. That's for feature by scale. Okay, so should I draw it on here?
Sure, if you want. Yeah.
Oh, how do I go back again?
Yeah, like over here you have undo and redo.
Oh, yeah.
And you have straight line drawing tools right there if you want.
So we have
Yeah.
that.
Yeah. Go ahead.
Here, I guess it's the system is 494. Here's 490. Sorry, that's so bad.
It's okay. Don't worry, you'll get better at it. I have a writing pad, that's why I can write really easily.
So this is the mean, and then the standard deviation is 92.
Mm-hmm.
So it's so 402. 402 is like right here first standard deviation
Mm-hmm.
to the left, and then whatever, and then 402 minus 92, which is 310.
Mm-hmm.
Oh, no, sorry. 310 is right here, so 310.
Okay. And what would go above this line? What would go above this line?
Sorry.
What would go above the line? What are you gonna draw above the line? Or on top of it? There you go. Okay. Yep.
Yeah, and then have the standard deviation above here.
Yep. Yep. Okay. Sorry. I mean, I want to. I don't mean to interrupt. I apologize, but obviously, like your time is very valuable, and so let's keep it moving. I just wanted to be convinced that you knew what you were drawing here, and what that you knew that we're on the same page. That the drawing that you needed to draw was this. I'm convinced that you know what you're doing. Okay. So let's go to the next one. B. Sorry, say that again.
I don't really
Yeah, exactly, exactly. Like on a similarly set up question, you should always be guessing like, oh yeah, this number and this number best has to do with the mean and standard deviation given, and no surprise. If you take,
Yeah, well,
yeah, go ahead.
so between 402 and 497, I guess. Uh, well, 402 is one standard deviation below the mean,
Yep,
and 678 is
feels like two. I don't know. Is it?
I'm just checking on my
It's
calculator.
okay. I'll do the same. I'll follow you. 494 plus 92 plus 92 is 678. Yeah.
Yeah, so one standard deviation below and one standard deviation above.
Or two. Go ahead.
Yeah, but another standard deviation.
Hmm.
So that's 8% here.
I could do the drawing for you if it's easier. But yeah, we have.
I'm doing it on my team.
I got you. So, you have something that looks like this, and now talk to me. So, how should we deal with this?
So what I'm doing is I started first through 68% from standard deviation below and above.
Mm-hmm.
Now I have to add the data because it goes two above.
Mm-hmm.
And then which is 27 divided by 2,
Okay. So,
right?
yes, exactly, because we already did that part. Yes, excellent. Good job. Good memory.
68 plus 13.5. So I think it's 81.5.
Yeah. So we can do this. 95 divided by 2. That will tell us how much this is. Plus 68 divided by 2. Um, what I wrote make sense?
Oh, yeah. Well, yeah.
Okay, cool.
So what was your final answer?
Oh, sorry. Hold on. 68 divided by 2. I got 81.5.
Yeah, I got that.
Okay, great. Beautiful. Okay. So next is go ahead, C.
The mean score for U.S. students was 41. Proportion of all scores were below the U.S. mean. The mean score for U.S. students. Okay, so
Mm-hmm.
we took this one. So we have 4.
I can give you a clue. This time we need to use this um, equation.
Oh, really?
Mm-hmm.
Okay, so
Well,
Z equals
yeah,
oh yeah, Z equals 481 minus 494 over 92,
yeah, exactly.
which is negative 13 over 92.
Mm-hmm. Let's see.
Negative 13 divided by 92 is negative 14%, basically.
Okay. Sorry. 481.
Or sorry, no, it's just 14 or negative 0.14.
Okay.
Negative 0.141.
Yeah.
So then
492. Yeah.
when
4.
I have the score, what do I do? Because we don't get that thing, the charts. What would I do?
Yeah. Divided by 92 is negative 0.119. Sorry. So wait, and when you calculated this, what number did you get? I got negative 0.119.
Oh, really? I got negative 0.141.
Okay, so maybe it's because I wrote 481. I don't think it's 481. Um, yeah, it is 481.
No, you wrote 492. It should be
Oh, okay. Okay. Sorry.
for the mean.
I got you.
Yeah.
Okay, thanks. Sorry. So,
So it's 0.141 now.
okay, negative 0, 0.141. Okay, you have, Tyler, here, you have to be given the z table, because if you're not given the z table, then you will not be able to say the probability or the proportion. So coming back to the z table, though, now that you've got that number, where would you go? Sorry, here. The negatives are here. Mm-hmm. Mm-hmm.
So the negative point one, and so it's like all the way to the bottom.
Mm-hmm. I got you.
One. I believe it would be like, wouldn't it be like right here?
Yeah, exactly. Because the fifth column is 0.04 exactly. Good job. So I'm happy about your ability. Yep. I'm happy about your ability to read this. Yeah, excellent. I mean, I went through the questions on my own ahead of the session, so I know the answer. I have kind of committed the answers to memory, and that's correct. The easy ones I didn't bother, like finishing all the way through. But anyway, okay. So next question is, well, okay, yeah. So D.
So what proportion of all P9 were above 700?
Mm-hmm.
7, right. Oh, so I'm going to do the same thing here. So 700, or no, so C equals 700 minus 494 over 92.
That's right.
700 minus 494 divided by, I got 0.024.
You got 0.024.
Yeah.
I have 2.23.
Oh, really?
Yeah,
Oh,
it's okay.
oh. Wait, did you do 700
Uh huh.
minus 494?
Uh huh.
Which is 206.
That's right.
And then 206 divided by 92. Oh, yeah, there we go. I got 2.23.
Okay, cool. Now coming back, um, like sorry, so 2.23. So we got to be on the positive z table, blah blah blah. But here we are, and so what would you do? 2.2, yeah, because there's no extra decimal. Exactly. So he said 0.978. Okay. Yep. 0.978. Yeah, there's a little bit more change, but the table isn't precise anyway. Uh, so so we have z equals not the z-score, but the area p of z is like 0.978. We said. Okay, but read the question carefully. What's the answer to the question? There you go. Beautiful. Yes, great. Say what again? 0.022, yeah. And if you have to say it as a percentage, because frequently they're asking for a percentage, you just say 2.2%. Exactly. Great. Okay, cool. And next for C, calculate the and interpret the 34th percentile of the distribution.
Yeah.
So how do we do this? So have you done questions like this in class?
Yeah.
So then when you get to these parts, how do you, without the table, do them?
You be using the table.
Okay. Okay, so what do you think about this one?
For this one,
Mm-hmm.
and I
Yeah, absolutely. But I'm curious what you're gonna do with the z table.
So I was gonna, so, yeah. Oh, wait, yeah.
Hmm.
Maybe can't I like find 34% and work backwards?
Yes, absolutely. That was my curiosity. Exactly. That's what you must do. There's one number closest to 34 and only one number in the whole z table. So, uh, like circle it and I'll tell you if you got it.
I'm trying to find it. Where?
Hmm.
Oh, up here somewhere. Oh, maybe is that a negative?
Sorry, say that again.
Is it on what? Is it
Uh-uh.
negative?
It's on here. It's on here.
Can't find it.
It's right here.
Is it at
No, no,
6.2?
no, no, no. You're right. You're right. My bad. It's not there. It's not there. My bad. Like point 34. You said right. Point.
Yeah.
My bad. Um, three. Oh yeah, you're right. Like so. No, 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 no. I had found it. Like so. It's point three is here, and then the extra decimal, the four, is right there.
Oh, okay, yeah, that makes sense. So it'll be right here.
Mm-hmm. Okay.
Wait, wait, would this be what above?
Nuh-uh. Cause look at where point three four is. The point. Oh yeah. No, no, no. My bad. You're right. Yes, it's the one above, right there.
Yeah.
Okay. So is this the final answer?
Sorry.
Is this our final answer?
No.
Okay.
So
Uh,
now would I do 0.6307
no, Tyler, I'm
equal?
so sorry. I'm so sorry on this one. Like I guess I was doing too much statistics and like made a mess of my head. My bad. On this one, we're not doing it correctly. We went after z value. You said correct earlier when you said we gotta work backwards. We need to find area that's 34%. No,
We need to find.
the area needs to be 34%.
Oh, okay. Sure, yeah.
Okay,
We do
so
that.
you are right. We have to go to the negative table.
I'm gonna find it here.
Mm-hmm.
0.0. Oh, wait, right here.
34%. That's 3.4.
Oh, yeah.
It's okay. I can help. It's somewhere over here.
Oh, yeah.
Exactly, right there.
Here, like right here.
Uh huh.
Here.
Uh huh. And what z value does it correspond to? Oh, the one you picked is better. Yes. What z value does it correspond to?
Negative negative 0.41.
Exactly. So let's go back. Negative 0.41. So we'd be like negative 0.41, and then what?
So that's
Uh huh.
negative 0.41 equals equals x
Yep.
minus 494
Yep.
or 92.
Exactly. So
So that, yeah, that's like multiply each side by 92
there you go.
and then add 494.
That's right. What did you get?
Negative 0.41 times 92 I got is negative 37.72
Mm-hmm.
and then plus 494 I got 456.28 is the 34.
Yep, that's what I got. Also, I wrote it down. And so, what's the interpretation?
Uh, Sorry.
What's the interpretation?
That it's below the mean, I guess.
That's true, but it's saying like sorry, it's saying that like 34% or fewer of the PISA scores were below 456.
Oh yeah, sure.
Okay, cool. All right. Next page, and I don't know if we want to like um, go through these. I guess we can. Like, go ahead and read it because like the first part A, B, and C are very repetitive to what we have done, but read them and just make sure that we can do them.
Right.
Okay. You disconnected.
Oh, oh yeah.
All good.
All right, yeah, it's good now.
Go ahead.
So for example, Phil.
Yeah.
So okay. What percent of the large width are too small? So the mean diameter is 3.98 deviation. Okay, so how would I find what percent of large width are too small? So what? Oh, I think I get it. So
Mm-hmm.
the mean is 3.98. Then one standard deviation would be 3.96.
Mm-hmm.
The next would be 3.94. With everything after the 3.9. But then to be um, wait, sorry, what is it? 65% and then
Yeah, 68 and then 95 and 99.7.
58, 95, 97.9. So
What are you doing for this one?
I'm trying to figure out how much information there is
Below what?
below the set, below two standard deviations to the left.
Um,
Which I got to be like, is that wrong?
well, yeah. Why would you not do P of Z is less than um, uh, P of Z is less than 3.95 minus 3.98 over 0.2 um, plus P of, what do you think I should write on this part? P of Z is, well, see, like the lids have to be between 3.95 and 4.05. So, like, you want anything on, sorry, go ahead.
No, yeah, I think 3.95 or 4.05.
Yeah, exactly. So you go P of Z is greater than, on this part, it's 4.05 minus 3.98 over 0.2. And you would look at the Z table both for this and for this, find the areas, uncouple them, because anything outside of those will not fit.
Oh, okay, yeah.
Hmm.
But, it's the same thing as before, essentially.
Yeah.
Okay, yeah. So I get those. C is just
Yeah, are made with small amount of plastic. Sorry, hold on. Stretch. Okay. Yeah, so the next question is the one question that I found confusing because you can read it. I guess you can read it and have you read these questions already?
No.
Okay. Well, you can read it once you have a chance to read it when we talk on Thursday. We can discuss it. But this is the one thing I want you to ask. Like, ask your teacher. I mean, I will figure it out, like, with a little bit more time. But ask your teacher, what am I supposed to use for X in this case? Because it's obvious that. Sorry, go ahead. Yeah, so what you're supposed to do is either change the standard deviation or the mean. So in E, you're supposed to change the mean, and F, you're supposed to change the standard deviation. Now, so in E, it says if the mean diameter stays, fine. So if the mean diameter stays to that, then less than 1%. Well, we know that 1% is 0.01, but because we know by symmetry, like the tail could be like 0.01 basically is the left tail and the right tail, we got to divide that by 2. Fine. So now we know that the z score that we want is for an area of 0.0005. That's half of 1%. So I looked up the z value for that. And hold on, what did I get? Z value was negative 3.9. Now, if you use this z value, then the equation you'd write is negative 3.9 is equal to x minus the mu is kept the same, which is 3.98. And then the standard deviation is unknown. So you are after, and this, yeah, you are after the standard deviation here. But notice that in this equation, there are two unknowns, x and the standard deviation. So you should, like, the one question I want you to ask your teacher. I will figure it out, as I said, and I have resources, people I can ask also, but ahead of Thursday. But ask your teacher, like, show him this much and be like, what am I supposed to do for x here? And if he gives us a clue, fine. Otherwise, again, if you don't figure it out or he doesn't answer it, I'll answer it. Okay, cool. So let's go. Thanks. Let's go to the next page. Well, the next question actually, I wrote. I looked at your writing and your solution. It looks like you figured it out on your own.
Yeah, I got that one.
Okay, cool. Um, and then, well, yeah. So on the next page, you have method one, blah blah blah, assessing normality. They basically said it there, right? Like, so, it says use a stem and leaf plot or a histogram. Um, I'm sure you know stem and leaf plot. I talked about a histogram earlier. So
Yeah, I know that.
yeah, so if you choose to go with a histogram, it's literally the first drawing that I drew, which is you're looking for this kind of a shape. And if you choose to do a stem and leaf plot, if it's normally distributed, you're looking for this kind of a shape. Um, so something that's symmetric. And otherwise, as it said there, you can find the mean. You can literally find x bar and do the z score and calculate the 95% and so on. And if you need to see like how you could have used the 68, 95, 99 rule to assess that this is normal, I can work with you on that. But I want to accomplish a little bit more today, so let's see. We're on time, so I guess, like, just to not test your stamina or attention span, like, I'll leave the next question for next time also.